All right, welcome to MCR 4, day 12. So we're going to look at exponents today and get into some of the exponential modeling. So to start exponents, they're a way of just writing repeated multiplication. So if I wanted to write 5 times 5 times 5 times 5, that would be 5 to the 4th power. The 5 is my base. That's the number you're multiplying. And the 4 is your exponent, which is the number of times you're multiplying. So what I have below through here is just some reviews of exponent rules. Feel free to look those over, spend some time on them. If you know them, great. Otherwise kind of read through them. The two we're really going to focus on are the fact that anything to the 0, except for 0, is 1, and anything to the 1 is itself. And then it's worth noting what a negative exponent does. But the rest of these you can read through on your own. So down here, to give a little review of how they would work, they come under PEMDAS second. So it goes parentheses, exponents, multiplication and division, addition, subtraction. So on something like this top row, if I had an x of 2, this one would be 2 times 2, which is 4, 2 squared, which is 4, 3 times 2 squared, which is 12, because it'd be 3 times 4. And then this one over here would be 3 times 2 squared, which is 6 squared, which is 36. So just a few quick ones to note. With the 0, 2 times 0 is 0. Here's where 2 to the 0 is 1. And then the rest of these would 0 out because you're multiplying by 0. So feel free to look at the answer key if you have questions on those or spend a little bit of time on them. What we want to spend our time on is how these exponents apply to exponential growth. So when we have our geometric sequence, 5, 10, 20, 40, what we're doing is we're multiplying by 2. So our PO, our initial value, is 5. To get the 10, we go 5 times 2, which is 10. To get the 20, we go 10 times 2, which is 20. 20 times 2, which is 40. And that's this recursive formula. So our recursive one uses the previous term. Now, what we're also doing is that first one was 5. 5 times 2 is 10. Then you could do 5 times 2 twice, 5 times 2 3 times, etc., because that's also what's happening. This 20 is 5 times 2 twice. The 40 is 5 times 2 3 times. 1, 2, 3. So if you're getting the idea, depending on which P you're looking for, if you're looking for P5, you would multiply by 2 5 times. So that's that explicit formula. And just to review, recursive uses the one before. Explicit gives you at any point in time. So if we grabbed out this explicit formula because we wanted P to the 6, that would be our initial value, 5 times 2, 6 times, or we could do the fifth term, the fifth one, 160 times 2. Now in the calculator, if you want to type in 5 times 2 to the 6th, it's 5 times 2 caret 6. And you need to have that button on the calculator. Otherwise, it's not going to be as fun. So here are your two formulas for those sequences. So recursive, you take the previous term, multiply by R. Explicit, take the initial value and multiply by R to the n. And then R is that common ratio that we're looking for. So if my numbers are 5, 20, 80, it's the 4. Or it could be a growth factor. So down in this box, say you're increasing by 10%. That 10% is your R, but when R is a percentage like that, in our formula here, you're going to write it as 1 plus R if it's growing, 1 minus R if it's not. Because in order to increase by 10, say we started with 100 things. If we take 10% of that, it's just 10. That's not an increase. So we're doing 100 plus 10% of 100, which is the 110. So the 1 is the original 1. There's my R, and then I'm multiplying it by that 100. So if it's a percent, it's 1 plus or minus that number. So if it's a growth rate of 2, then your R is 1.02. If it's a decrease rate of 8, then it's be 1 minus the 0.08 or 0.92 for your R. So over here, if we wanted to find the 15th, P15 of that geometric sequence, we would do Pn equals PO times R to the N. And because we already have the number, it's a 2, it's a 4, we don't have to do the 1 plus. So P to the 15 is the initial. We're doubling it to the 15 power. Very quickly, this grows to be 163,840. All right, so just a little bit of work with how you would plug this in. If it looks like 2A, it would be 1.25 carat 18. If it has a number in front, it's okay. You just type it in anyway because your calculator knows order of operations. So a few of these, just to make sure we're doing okay, would be 150 times 1.75 carat 10, and you would get 40,408.4 because it says round to the 10th. This one would be 2.3 carat 8, which is 783.1. And this one would be 3.09, that's tripling, carat 16, which would give you 69 million, etc. So just a few to work on with your calculator. Okay, so here are some practice problems for us to try. So if we are looking at these, just remember, here is our formula that we're trying to get. If it's a sequence, the R is just what it is. If it's some type of percent, we need to do plus or minus R, depending on if we are growing or decaying. So for this one, we're multiplying by 3. How do you get that? Take any one term and divide by the previous, and you're told it's geometric. So our P10 would be PO is 1 times 3 to the 10th power. And then we would grab that answer out. For this one, our P19, now this one looks a little more complicated. We need to take any one term and divide by the previous if it's not as obvious. And that gives us 1/2 for that number. So P19 is going to be equal to the original starting point times 1/2 to the 19 power, which happens to be a nice, pretty 1. Okay, and then to grab a few on here, now we have the growth rate. So now our formula is going to read Pn equals PO 1 plus R to the N, because it's now a percentage. And just to make sure we're careful, we need to take that 0.73 and divide it by 100 to get the correct decimal. So what will it be in 5 years? Okay, so P5 will be the original starting point times 1 plus that 0.0073 to the 5th power. So that'll end up being 235,374. And it should be growing, otherwise something went wrong. All right, and then last one we'll work on this page is question 7. What would it be in 2020? So it's based on 2010. So to get to 2020, our N is 10. So that's important that it's years since. And then we're given the formula. So we need to type in 4,600 times 1.072 carat 10. And that'll give us our 9,219.46. All right, then you want to complete your day 12 assignment and have a wonderful day.